Okay, here we are, the end of chapter review. Number 1, we've got to find the mean and the variance given this probability distribution. So the first step is we're going to have to find out what the probabilities actually are. We're going to take all these given probabilities with their variables, k, and we're going to add them all up and make them equal to 1, and then we're going to find out what k is. And once we find out what k is, we're going to substitute that back in so we can find each one of the individual probabilities. So we get k is equal to 9 over 14. 1 minus 9 over 4, or 9 over 14 is 5 over 14. 2 minus 3 times 9 over 14, and so on, give us these figures here. So now we've got our probability distribution properly filled out, and all we got to do is find the mean. That's the expected value. We're going to take each one of these x's times its probability and add them up. So it's simple enough. We're going to write down what we're doing. 1 times 5 over 4 plus 2 times 1 fourth plus 3 times 3 sevenths plus 4 times 1 seventh. And then we're going to let the calculator do the rest of the work. We're going to type it all in and find out what we get. So here's our calculator, and we're going to go ahead and enter in the information, and we're going to try to be careful that we get it in there accurately. And when we're done, we'll have our answer. We find out the expected value is 33 over 14. So now we need to find the variance. In order to find the variance, we're going to do very similar we're going to take each x and square it times its probability, and then we're going to subtract the expected value squared. So I'm going to go back on my calculator, and I'm just going to replace all these numbers I put in before and square them. And double check, make sure I got everything right. Put minus, and then 33 over 14 squared, and that's going to give me my variance, 241 over 196. And then we got to make sure that we write down our method so we're clear about what we're doing. Numbers can't just appear out of nowhere, and then we're going to fill it in with our answer. 241 over 196. All right, let's go on to the next one. All right, page 162, we're looking at number 2. We've got a table here. It's a probability distribution, but they're missing one of their y values, and they're calling it q. They do give us the variance. They tell it's 1,385.2. And they want us to show that it's going to equal q squared minus 61q plus 624. Well, we know the formula for variance, so we're going to have to find the expected value and then the sum of the x squares. So let's go ahead and start with the expected value. If I want to do that, I'm going to take all the x's times their probabilities. That's simple enough. And I'm just going to treat that variable like a number. So 0.2 times q is 0.2q. And I end up with 24.4 plus 0.2q. And now I'm going to need the sum of the x squares times their probabilities. And all I'm going to do is do pretty much the same thing, only take these first numbers and make them squares. So the q is going to become a q squared, and that's going to end up being 2080.4 plus 0.2q squared. All right, now I'm going to go ahead and lay out my variance formula. The sum of the x squares times probability minus the expected value squared, so that way people know what I'm about to do. And I'm going to put the variance here, and then I'm going to put the sum of the x squares times the probabilities here, and then I'm going to subtract the sum of the expected values, which is going to be 24.4. I'm going to rearrange it to 0.2q plus 24.4 squared. All right, so one first thing we can do is we can go ahead and make this equal to 0. It's a quadratic. We're obviously going to have to make it a 0 eventually. So we can go ahead and subtract these two numbers, and we'll get 695.2. This is going to stay the same. Now, I've got to square this before I multiply it by -1. And this is just squaring a binomial, a weird one, I'll admit, but it's just a binomial, and we could use the FOIL method. It's going to be 0.2q times or plus 24.4 times 0.2q plus 24.4. So if I'm going to FOIL it, I'll do my first. 0.2 times 0.2 is 0.04 q squared, and then 0.2q times 24.4, that's going to be 4.88q. And then I'm going to do that again because there's 1 and then they're exactly the same, so that's going to be number 4.88q. And then 24.4 times 24.4, that's going to end up being 595.36. So now I'm going to put that in there. I'm going to combine the two 4.88q's. So I'm going to combine those terms, and I'm going to get this. Now, the thing is, you notice that minus sign out front. That's like multiplying that whole thing by a -1. So I'm going to go ahead and do that because I can't just minus the first thing. I have to minus the entire thing. So I'm just going to go ahead and distribute the -1. I'm going to get this. And see, now it just becomes an issue of combining like terms. I'm going to put my q's together, and I'm going to get 0.16q squared. Put these, let's see, the 0.97 or 9.76q, and then subtract these numbers here. I'm going to get 99.84. And then I'm going to divide everything by 0.16, and that's going, because they all do divide by all 0.16, and I'm going to end up with q squared minus 61q plus 624, which is what they wanted me to end up with. And they want me to solve it. So now I'm going to go over here and go to menu and press A, and then polynomials of degree 2. I'm just going to fill in these coefficients of 1, -61, and 624 as the constant. I'm going to press enter, find out my first answer is 48, and then my second answer is 13. So Q could be 48 and Q could be 13. So I write those down. And then in part B, they want me to go ahead and they want me to find the biggest possible expected value for Y. Well, the biggest possible expected value of Y is going to be where Q is 48. And I've already got an expression in part A for the expected value. It's 24.4 plus 0.2Q. So all I've got to do is substitute the 48 in for Q, and I'm going to get 24.4 plus 0.2 times 48, and I'm going to find out that the expected value for Y would be a 34 in that case. All right, let's take a look at the next one. In problem number 3, we've got an investment company, and they've got this table about profit percent and the probability of each profit percent happening. And they want to, and this has happened over a period of 3 years, and they want us to calculate the expected profit on an investment of $50,000. Now the first thing is going to be we have to find the expected percent of profit, and then we're going to multiply that times the $50,000 to find out what kind of profit we could expect on $50,000. So the first step is to find this expected value for the profit percent. And we're just going to use the expected value formula. We're going to multiply each one of these x's times their p's, and then we're going to add them all up. And when we do that, we're going to find out that the expected profit percent is going to be 13.35%. And now I just got to change this percent to a decimal. That's 0.1335. Multiply it times the $50,000. And I'll find the expected profit is going to be $6,675. All right, let's go on to the next one. Okay, so number 5, we've got a die. It's got numbers 1, 2, 3, 4, 5, and 6 on it. And we've got this probability distribution, but it's not filled in. So if I take 4p plus 0.4, it's going to equal 1, meaning that p has got to be 0.15. I'm going to go ahead and put those in my table. 0.15, 0.15, 0.15, 0.15. You would probably just write it below. Anyway, this die is going to be thrown 3 times. We want to know the probability that the score is at least 4 on at least one of 3 throws. All right, so that's a lot of at leasts. So the first thing is we got to find the probability of getting at least a 4. Well, at least a 4 means I could get a 4 or a 5 or a 6. The probability of getting at least a 4 is 0.15 plus 0.2 plus 0.2. It's going to be 0.55. Now, if getting a 4, 5, or a 6 is a probability of 0.55. That means that getting a 1 or a 2 or a 3 has got a probability of being a 0.45, because that's everything else. All right, we're going to use this information. We need to know now how often that can happen, or what's the probability of that happening in one of 3 throws. That means that we're interested in 1 throw, or it happening in 2 throws, or in 3 throws. So we have to look at each situation. We'll start with just happening on 1 throw. On this first throw, we end up getting a 4, a 5, or a 6. Now, the other 2 throws, we get a 1 or a 2 or a 3. Now, we multiply those probabilities together to get the probability of that happening. The thing is, though, it didn't have to happen on the first throw. Maybe it happened on the second and maybe on the third, because that's still just 1. So we got to figure out how many different ways this could be arranged. Well, if you take a look at it, 0.55, 0.45, 0.45, that's 3 factorial divided by 2 factorial, because the 2 0.45s are identical. Anyway, we're going to multiply that by 3. And that gives us this probability here. Now, what if it only happens on 2 throws? Well, that means I get a 0.55 and a 0.55 and a 0.45. Now, in this situation, we're doing on the first throw and the second throw. But again, that could happen 3 different ways also. So we can look at the third situation where it happens on all 3 throws. That's a 0.55 times 0.55 times 0.55. Well, that can only be arranged one way. So I just don't have to multiply that by anything. I'm just going to multiply them together. And I'm going to get that probability of 0.166375. And now all I've got to do is add all this up, because they're all instances in which I'll be happy with. The probability would be 0.908875. Okay, let's go on to the next one. In problem number 8, we've got a fair spinner. It's got sides labeled 0, 1, and 2. And then another fair spinner that's got sides labeled -1, 0, and 1. So let's put a possibilities table together here. Now, what's going to happen is that the score is going to be equal to the sum of the squares of the numbers that come up on the spinner. So what I'm going to do is I'm going to write those below each one of the numbers as they come up. Each one of these numbered squares are going to be in blue, because those are what I'm actually going to add together. Now, if I get a -1 and a 0, the score is going to be 1. And if I get a -1 and a 1, the score is going to be 2. And then so on. And I'm going to fill in the table. So now in part A, it says to list the possible values for x. Well, x could be a 0, a 1, a 2, a 4, or a 5. Those are all the scores we see in our possibility table. Now, in part B, it says draw the probability distribution. Now, since I've got the possibility table already made, this should be pretty easy, because I've got all the possibles, 0, 1, 2, 4, and 5. And they're all out of 9, so that's going to be for 0, 1 out of 9, and 1 is going to be 3 out of 9, and 2 is going to be 2 out of 9, 4 is going to be 1 out of 9, and 5 is going to be 2 out of 9. Those are my probabilities. All right, part C. Given that the score is less than 4, find the probability that a score of 1 is obtained on at least one of the spinners. So the probability of the spinner, we spin a 1, and the score is less than 4. Well, in our table here, we can get rid of this last column, because these are the scores that are where less than 4. And now all I got to do is figure out how many times a 1 was spun in order to come up with them. Well, this 1 and -1 resulted in a 2, and this 0 and 1 resulted in a 1, and then this 1 and the 0 is a 1. Here we go. We got 4 of them, because these last ones don't involve 1s. So that means that there were 4 out of 6 possibilities, or 2/3. That's the probability. And then in part D, it says to find the exact value of A such that the standard deviation of x is 1 over A times the expected value. Well, we're obviously going to have to find the expected value, and we're going to have to find the variance, which will lead us to the standard deviation. All right, so let's go ahead and start with that. We can use our probability distribution table, And now what we're going to do is sum up our x's times our p's. And that's going to be 3/9 plus 2 times 2/9 plus 4 times 1/9 plus 5 times 2/9. And then when I add those all up, I'm going to get the expected value is going to be 7/3. And now let's go ahead and find our variance, which the variance is going to be the sum of the x squares times our probabilities minus the expected value squared. And so I'm going to do pretty much what it looks like to be the same thing. It's going to be 3/9 because that's 1 squared, but then it's going to be 4 times 2/9, and then plus 16 times 1/9, and then plus 25 times 2/9, and then I'm going to subtract 7/3 squared, and that's going to give me a variance of 28/9. Now once I've got that, I'm going to take the square root of it because the standard deviation is equal to the square root of the variance. And so I'm just going to do the square root of 28/9, which is going to be the same thing as the square root of 28/3. Now, I'm going to take what they gave us in the beginning, and I'm going to fill in everything I know and find a. So 28, the square root of 28/3, is equal to 1/a times the expected value, which is 7/3. And what I can do is I can multiply both sides by the reciprocal of 7/3, and then I'll get rid of the 7/3. These 3's will cancel out. That's going to give me the square root of 28/7 is equal to 1/a. And then all I can do is cross multiply. And you know what? I think what I'm going to do first is I think I'm going to look at that square root, the 28. I think I'm going to reduce it. So this is the same thing as 4 times 7. So the square root of 4 is going to be 2, square root of 7, and then over 7. Now I make it a 1/a. And when I cross multiply this, I'm going to get 2a times square root of 7, equals 7. And now all I got to do is get the a by itself, divide by 2 square root of 7, and the a is going to equal this. Now the problem is, I typically don't leave a square root in the denominator of a fraction, so to fix that, I'm going to multiply both the numerator and the denominator by square root of 7 over square root of 7, and then I'm going to end up with the square root of 7/2. That's what a is going to equal. And that's all there is for that one. Let's look at the next one.